Good morning and welcome to a new episode of the EEF Talks. I'm Paola Rusconi, Investment Manager of the European Energy Efficiency Fund, and today I'm pleased to have with us Marco Baresi, Director of Marketing and Institutional Affairs at Turboden. Turboden, just as a matter of quick introduction, is a company of the Mitsubishi Heavy Industries Group and one of the main players in the production and management of technologies for the heat exploitation. This is the very core of what we're going to discuss today. Hi, Marco.
Hi, Paola. Thank you for the invitation. Good morning.
Thank you for coming. So you're also Vice President of the European Geothermal Council, of the Italian Association for Cogeneration and Waste Heat Recovery. So there is lots we could cover and talk about. However, today, especially given that we hear politically a lot of talks and thoughts around how to restructure the heating system and make it more efficient for Europe in the years to come, but sooner rather than later. I'd like to go deeper with you on how to bring sustainable and efficient heating or cooling to our cities, to our homes through the technologies you are an expert about. So if you can give me just a quick overview of the technologies we are talking about and what are the main relevant ones to connect the production sites for heat recovery to the cities through district heating, just in a very simple term.
Okay, Paola, let me spend a few words about Turboden that could be helpful for this discussion, for this podcast. Turboden is a company specialized in design, manufacture, and maintenance of organic ranking cycle system. Ideally suitable for distributed generation. So it means to have low temperature heat, low to medium temperature heat exploited to generate power and heat at different level. We have the possibility to start from multiple sources, for example, solid biomass or geothermal, or waste heat from the so-called hard-to-abate industrial processes, like, for example, cement, steel, and glass. The explanation of waste heat recovery, we estimate that waste heat recovery is an efficient way to valorize the excess heat then otherwise is wasted in the atmosphere. These waste heat represent currently a CO2-free sources. In very brief, you have in one side, you have waste heat at different temperature level, the so-called heat supplier. On the other side, the users of heat, for example, district heating or industrial company, is the so-called user. Due to the different level of temperature, often is not possible to use the heat recover directly, for example, to the district heating. We have different range of temperature, starting from 20, 30 degrees of typical heat from sewage treatment, or a data center, the temperature is higher, or industrial processes where we have a various stream at different temperature level. The temperature of operation of district heating on the other side is various. We have district heating developing in the 18 and 19 with highest temperature of operation. The recent one, the so-called low temperature district heating, have lower temperature of operation. How can you match both from one side waste heat recovery and from one other side the users of district heating?
It's interesting that the starting point is the delta of temperatures you have on site, where there is a heat producer and at the end of the value chain, a heat consumer with different temperatures. Can you give me an example of a project where you had different players sourcing this type of project?
Yes, Paola, you can better understand the picture with a concrete example. I have a project in a steel factory in the north of Italy. It's a manufacturer of high-quality steel for automotive and special application, and it is located in the north side of the city. is a city of 200,000 inhabitants, and this is a unique situation because since 2016 they have a waste heat recovery system installed, recovering the heat from the hot gases residuated from the primary circuit. So it means high temperature and extremely high availability of waste heat. We are talking about 100 degrees and high flow rate. The steel factory, in fact, is called hard to abate and is similar to other hard to abate sectors like cement, glass, or so on. To give numbers, the 10 megawatt thermal waste heat recovered fed the district heating operated by the local utility during the cold season, providing heat for 2,000 families. And on the other side is converted in power during the hot season, generating more or less 2 megawatt electrical power through the ORC turbo generator, mainly for self-consumption. This is a way to reduce the electricity from the grid, saving money in this period, particular of crazy cost of electricity. The electricity produced is equivalent to the needs of 700 families. And by using a matrix of today is equivalent of 1.7 million cubic meter of natural gas saved. And it is impressive because this action is done only by recovering a waste heat, so something that otherwise is wasted in the atmosphere. But this is the first part of the story. We are talking about the high temperature, high flow rate. The second part of the story, second part of the project that will be put in operation in the next months, will allow to recover additional waste stream from the secondary circuits of the steel process. The secondary circuit is used for cooling the electrical furnace and residuate hot water at 775 degrees, so extremely low compared to the primary circuit. On the other side, we have the district heating network of the city that needs temperature in the range of 95 degrees to 120 during winter. In this specific case, the suitable technology to apply is the industrial heat pump. So, for primary circuits, they recover the waste heat to generate power with the ORC. From the secondary circuit, low temperature, low flow rate, we are able to apply an industrial heat pump to feed district heating. The working principle of large heat pump is similar to the domestic heat pump for heating purpose. So basically you inject the electricity to heat pump to increase the temperature level from a low temperature to a suitable height one. But lower the heat leap, higher the efficiency of the duty, the so-called COP, the coefficient of performance. So at the end of this investment, this steel company will have will be able to valorize two different waste streams and will be able to increase the sustainability of this steel industry and integration with the city, giving an extra flexibility and also giving two additional revenues, one from the electricity, from the power, and one other from the delivering the heat to the district heating.
Okay, this is interesting because we see that what is a resource unvalued before, the heat which is produced nevertheless to the industrial cycle becomes a resource, and on one hand saves money for the company itself, on the other hand generates additional streams of revenues through the injection in the district heating network. And that there are technologies which are able to exploit the entirety of the heat available at the different temperatures. So we talked about ORC for the conversion of heat electrified to produce electricity, and the heat pumps to take the lower temperatures and transform them in heating for the district heating network. I see that there are countries in Europe which are more advanced in this type of projects and solutions, and some others which are less advanced. But all in all, this is a type of application that we don't see too often, or that for sure we would like to see more and more. What do you think are the barriers and the blocking points to go really hard on these type of applications?
Yes, it is correct, Paula. Currently, the waste heat contribution to district heating in Europe is not so relevant. But the Energy Efficiency Directive under revision give a strong role with waste heat in the future energy efficient district heating by 2030 and 2050. So it means basically to reduce the use of fossil fuel by using, for example, more renewable heat and more waste heat. But there are currently barriers, not technological from my point of view, because from the technology point of view, it's important to continue R&D and innovation in order to increase efficiency, lowering the cost, the so-called learning curve. Paula, think about what's happened with photovoltaics, for example, installing gigawatts of power. We have gone from cost of €1,000,000 megawatt to €1,000 megawatt, the so-called learning curve. So we need to do installation to reduce the cost and to improve the technology. But the main barrier is the economic competitiveness of this solution. Let me give an example. Industrial heat pump feasibility is directly connected with the cost of electricity. So you need electricity to increase the heat leap from the supplier point of view to a user point of view. More the delta T, less delta temperature, less the efficiency. Less efficiency means more electricity needed. And what is efficiency from a thermodynamic point of view is less from an economic point of view. So it is relevant that policies still continue to promote this application and also will support it in the transition. An interesting point and an interesting path forward towards this transition happened days ago by the launch of the European Commission of the Repower EU package. In Europe, a strong acceleration of the electrification of heat was boosted by the Fit for 55 package under the Green Deal. But this was on July 2021. On May 18, so a few days ago, the EU released the Repower EU. Repower EU is a way to reduce dependency on Russian fossil fuel and to going deeper in save energy, diversify supply, and quick substitute fossil fuel by accelerating Europe clean energy transition, and also a smart combined investment and reforms. This package, when will be implemented in the next months, will be a boost for the introduction of this kind of technology, in my opinion.
So you already saw measures or actions in Repower EU which can address the difficulties of waste heat recovery and this type of projects we're talking about.
Yes, waste heat recovery is explicitly mentioned in the Repower EU package, and also there is a strong pillar related to the save energy and energy efficiency, mainly in buildings, private building, but also in industry. So it will be relevant to have this contribution for the future development of this technology, as I mentioned before. Another barrier, you asked me a barrier, another barrier is the this kind of investment are capital intensive. And so I see actors as EEF, for example, your fund, as a key actor to support transition in terms of finance and to promote best practice. Also to inform what we are doing today with this postcard, for example. But we need to cover the gap between the limited knowledge on the match between heat pump, for example, on this kind of technology, and process demand with key decision maker, industry, consultancy, utilities, and so on.
If I have to give you my own view on the barriers I see from an investment side, the interconnection between the different infrastructures which are involved in this type of projects. So the district heating networks attains a certain group of decision makers. Whilst the private side, the industrial side, in the example you made, but we know that the generation of heat can come also from ad hoc sites and production sites which are dedicated to feed the district heating network on one hand and the electricity grid. But the connection between production and exploitation goes through basically a partnership between private entities and public actors. And this is the key barrier, I would say, from my point of view as an investor, I have been able to appreciate over the last years, blocking this type, the true development of this type of market, which has its own shape. So it's in place and it's going. It's valued 60 billion a year of revenue, waste heat recovery. So it has substance already, but it could be much more than what we see right now, if only we could have a better engagement between the policymakers, the local administrations, and the private players, producers as you are, and industrial sites as well. I do hope that the engagement we see and we appreciate through the European Green Deal, through now REPowerEU, and all the measures in between, the action plans in between, will favor these type of synergies.
Yes, I agree with you, Paola, about one of the main difficulties is to match from one side the utility and the energy supplier that are able, for example, to recover the heat or to do energy efficiency investment, and from the other side the company, the industrial company that has a continuous process, but that could be subject, for example, to economic crisis or so on. We have done an interesting work in the last months with the EFIG, the Energy Efficiency Financial Institution Groups, created by the European Commission years ago, in order to define, for example, a de-risking scheme, and also to promote, for example, a risk insurance scheme, a public risk insurance scheme, in order to cover these two different approaches, more or less, in order to cover the energy performance contract guarantee. From one side, you have the industrial player that manufacture for 3,000, 4,000, 5,000 hours per year. And so the residual weight is available from these industrial processes. On the other side, you have to guarantee the utility and the energy supplier that have to do, for example, the investment in district heating and so on. So must have a sort of guarantee of this flow rate during the year. If you are an industrial player and, for example, there are some period of crisis or so on, you are not able to guarantee the supply of heat to the district heating. So one of the key points is to match these two different approaches. And for example, a risk mitigation scheme or a way to guarantee this energy performance contract could be a solution, as we have discussed a lot during the Energy Efficiency Financial Institution Group, the EFIG group at European level.
I see. So it's a matter of finding a way to cover the risk of lower volumes, lower activities on the private side, so on the industrial side, versus the investments a certain investor has to make to realize the infrastructure and guarantee the offtake of the production.
Yes, this is key. What you see from the industrial side and from the utility side, this is point for this kind of investment.
Okay, and said regarding the infrastructure itself, so realizing district heating networks to make this heat arrive to the homes and to the houses of people who will make use of it. Do you see this as something which comes attached easily, or?
Yes, from the technological point of view, there are no barriers to connect. Yes, of course, it's not simple. You need the engineering and you need the technology, but there are clear examples of project already realized. So it could be done without a big problem.
Yeah, okay, I agree. I think it's mostly a matter of political commitment and local administrations equally committed to authorize and realize these type of connections. Let's close with your very desire, if you only could make a wish and ask something, the one thing you would like to have from a policymaker to really unlock the capabilities and the potential of this market, what would you ask?
It's a good question. I've seen in the recovery and resilience facility some interesting point to exploit this opportunity. But in my opinion, and we must be most ambitious in the level of energy efficiency targets, for example, in industry, and allowing money for doing this kind of investment. For example, in Germany, Austria, Holland, and Denmark, they are pushing a lot. Other countries are a little bit more conservative. I believe Repower EU will boost this application wider. But to do this kind of application, you need a strong support from the policy and also from the financial point of view. So this is the question. Please valorize this waste heat because it represents a smart way to mitigate energy prices and gas crunch this period.
Yeah, and it's affordable. The technologies are there. It makes economic sense, and it's a true investment for.
Yes, and if I can add something, also
Sure.
is important also to promote a strong exploitation of the EU manufacturer. So only by pushing for this, the result will be full. Otherwise, if you will depend from foreign import of technology, we will have reached the goal only partial. It's a strong opportunity, but we have to design correctly this opportunity. And from the energy efficiency point of view, we have a lot of success story and a lot of important companies, manufacturing companies in Europe. So we have to valorize it.
We couldn't end better our talk. Thank you very much, Marco, for being with us. I'm pretty sure I will knock at your door again to talk about the lots of other things you are an expert about and you cover in your activity and which are related to energy efficiency and sustainable energy in Europe. Thank you so much. See you next time. Have a nice day.
Thank you, Paola. It was a real pleasure also from my side. Thank you.